Hi guys, today we're going to cover fetal circulation. Okay, fetal circulation is about the circulation of oxygenated, deoxygenated, and deoxygenated and nutritive blood between the mother and the unborn fetus. So we're going to focus on oxygenated and deoxygenated blood today, simplify things a little bit and get the concept across. And I want you to think about something. Now, the fetal heartbeat can be heard at about 5.5 to 6 weeks of gestation. And so that means that the fetal heart is fully formed, and so is its entire circulatory system. So now, with that knowledge, why would there be a need for structural differences in the fetal heart? So I'm telling you that there are, then, that is. There are structural adaptations, and that being shunts, that are different in the fetus than in the post-fetus. And we're going to learn about those. So why would that be? Anybody want to give me some feedback on that in the chat? Okay, so, I see some comments there, and somebody's telling me that, the lungs are not working. They're collapsed. There are no lungs. No, there are lungs. The fetus has fully formed lungs at this time, and everything else, pretty much. So the problem is that they're not functional lungs. And that's because of the amniotic fluid. So what we're going to do today is we're going to cover how fetal circulation differs from post-fetal circulation and why, and look at those structural differences, that allow for fetal circulation. So I'm going to list the main structural differences that allow this circulation. And then we'll elaborate them in a bit. The first one is the placenta. Then we have the ductus venosus over here. And then we're going to have something called the foramen ovale. And then last but not least is the ductus arteriosus. Okay, so in order to understand the adaptations in the fetal heart, or fetal circulatory system, it's good to know what kind of circulation we have in the post-fetal heart. Now, you've all studied this in an earlier chapter or course, so we're going to just do a little recap on it, and we'll just refresh your memory a little bit how our heart is a double pump with pulmonary and systemic circulation. So we're going to start with bringing deoxygenated blood back to the heart through our vena cavas. We have the superior and the inferior vena cava here, and both of these veins bring deoxygenated blood back to the right atrium, and that flows through the tricuspid valve to the right ventricle, up to the pulmonary trunk, and then to the right and left pulmonary arteries. Okay, so we want to think about that now. This will bring blood, deoxygenated blood, to each artery is going to go to a lung, and we're going to get some nice oxygen there. And the oxygen is going to go through the pulmonary veins, going back to the heart via the left atrium to the left ventricle, up to the aorta. And then we see three parts here, and then we're going to have 3 arteries that are going to bring this lovely oxygenated blood through all the tissues in the body. Okay, so the problem that arises then, you'll see, is that the pulmonary arteries in the fetus are going to have a problem, right? Because they're going to go to the lungs, and the lungs are not functioning and not accepting oxygen. They're not doing their job, and they're not oxygenating the deoxygenated blood. Okay, so let's take a look and see why this happens. All right, so we're going to call this pulmonary resistance, and we're going to take a look at the anatomy in the lungs a little bit. So if we look at our lungs, we go all the way to the terminal bronchioles, and we see that the functional anatomy of the lungs are the alveoli. So these are little sacs, membranous sacs, where we have diffusion of oxygen and carbon dioxide gases, and they're going to diffuse these gases with the blood vessels, the arterioles, and here they are. So the condition we have in the amniotic fluid is low oxygen, and we call that hypoxia. So what that's going to do is that's going to cause the large diameter of blood vessels to constrict. Okay, and that's going to cause something called pulmonary hypoxic hypertension, and that's going to cause resistance. So think of thousands of these little alveoli in your lungs, or the fetal lungs. You're going to have tons of resistance there. Now, how does blood flow? Blood flows from, it goes to the pathway of least resistance. It's going to go from high resistance to low resistance. Well, that's not what is happening in the fetal heart, right? Because you're going through the pulmonary trunk, which would want to flow to the lungs from should be higher resistance to lower resistance, but in the fetal heart, you're getting lower resistance to higher resistance. So it's a no-go, right? It's a no-go. So we say, we're going to have to bypass the lungs. So another question here is, where is the fetus? If it's not getting, the fetus is not getting oxygen from the lungs, where does the fetus get oxygen? Okay, that's a question for you. And everyone is telling me, okay, yes, you're correct. The placenta. Okay, the placenta. Okay, and this is where we see this tissue-filled placenta. Is we have mom's blood vessels and the fetus's blood vessels, and there's a connecting tissue, but the blood does not mix. Rather, there is an exchange between mom's blood, the materials, the molecules, and the gases, okay? And the fetus picks up those molecules and gases, okay? Here it is, more detailed. We're not going to go into the nitty-gritty details right now. We're just going to show you the blood vessels. We're going to show you the fetus's blood vessels. So we have two arteries, fetal arteries, and we have one fetal vein. Notice that the fetal vein is the red vessel, blood vessel. It's oxygenated. Okay, so we define a vein as a blood vessel going back to the heart, not whether it's oxygenated or deoxygenated. It's the pathway back to the heart that defines whether it is a vein or an artery, and the vein goes back to the heart. Okay, so we have two arteries and we have two veins. Okay, looking a little bit more into detail here, okay, showing the placenta, having the umbilical vein in red, moving from the placenta, carrying the oxygenated blood that mom gave. Okay, mom gave the oxygen. Now the embryonic vein, umbilical vein, is carrying that oxygen, okay, to our first shunt. And we call this the ductus venosus. Okay, the ductus venosus is a duct that opens into the inferior vena cava. The inferior vena cava is blue, deoxygenated. The blood will mix, and it's going to go to its first stop, which is the right atrium. Okay, so there's a mixing of blood, but there's plenty of oxygen there for the fetus. Okay, so the next port that you will go to is the right ventricle. Some of it goes there. Yes, some of it does, But remember that we discussed the high resistance in the fetal lungs, right? Well, that resistance in the fetal lungs is going back to the pulmonary trunk, which goes back to the left ventricle, which kind of backs everything up. It's like a pushing back resistance and causes some resistance even in this right ventricle. So all that pressure gives some pressure to the right atrium, and that causes an opening of our next shunt that we will discuss called the foramen ovale. And this causes blood to flow directly from the right atrium to the right ventricle. To the left atrium. Okay, so right to left atrium. So we're having blood go directly there. So let me show you that in a better picture. Okay, so it moves directly there. And from there, we're going to see that we do have blood, some blood, in the right ventricle. Well, that blood is going to move into the pulmonary trunk. So what happens to that blood? That blood is not going to move into the lungs. Too much resistance. So where does it go? There lies our last duct or shunt, and we call that the ductus arteriosus. And that's going to open up, and that blood is going to flow directly into the aorta, okay, bypassing the lungs again. And we know that blood that goes into the aorta goes to all the tissues in the fetus, okay? And that's our last shunt. All right. So just a little information about the ductus arteriosus. It's kept open by chemicals called prostaglandins. There's muscle tissue there, and it is kept open by prostaglandins. So if prostaglandins keep this duct open, antiprostaglandins will close it. So a pregnant woman will go to her OBGYN, and he or she will say, don't take anything that's an antiprostaglandin, and NSAIDs are antiprostaglandins, so ibuprofen is one of those that can actually cause a miscarriage. I'm not a doctor, but this is an example, and that can, because it can close up the smooth muscle, and then the baby doesn't get as much oxygen to their tissues. Okay, and I'm going to close this talk for now because we're over 10 minutes. Thank you.